Hi, and welcome to our first lesson for this new concept, reaction rates. So what is a reaction rate? A rate is the same as any sort of rate. So the rate of speed or the rate of time, these are all rates, something that moves over time, okay? So that is the rate of something. So nothing's different here. A reaction rate is just the amount of time that it takes for the concentration of reactants to break down over time or for products to be formed. Different things can affect reaction rates. Temperature, catalysts, the concentration, the surface area, or the pressure. So have a stop now. Pause the video and think of some ways in real life that you might have seen any of these affect the rate of which something occurred in real life. So for example, think about food. When we bake something, cookies, cake, we crank the oven as high as we can, right? We lift it up, we really turn the nozzle, and we crank that because we want it to be as hot as it can be, so it's cooked as fast as it can be. So when we want that to be cooked, we turn the temperature up. So when there's a high temperature, a reaction is going to occur quicker. Think about food another way though. When we make food that we want to last for days and days, or we want to eat later, where do we put it? We definitely don't leave it out on the counter because that heat is going to make that food go off. So we put it in the fridge or the freezer in a colder temperature where the reactions won't occur so fast. Obviously, it will go off at some point, but it will go off much slower than if you left it out on the counter. How about the concentration? We've all had cordial before. So when we put more cordial into the water, there's more little molecules and atoms of concentration, cordial concentration in the water. So we put more concentration in, then we can obviously taste that. We'll do an experiment. As our experiment showed on Tuesday, the higher the concentration of our trisulfate with our hydrochloric acid, then the faster we saw the result. How about surface area? Have you used a bath bomb before? Think about it. Think about how big a bath bomb is. It's about that big, right? But it takes forever and ever to dissolve. Whereas if you break it up into smaller bits, right, reactions would occur much quicker. That's because there's a lot more surface area that has to react in the bath. How about pressure? Back to food again. With pressure cookers, the higher the pressure, the higher the intensity, and the faster reaction occurs. And with catalysts, well, catalysts occur everywhere. It's not really one that we can really see as much, but think about it in real life. If you were running and then a bear started chasing you, that would be a catalyst for you to start running faster. So a catalyst is something that is added to a chemical equation, but doesn't actually change the products or the reactants. It just speeds the process up. We have catalysts in our body, for example, or enzymes, which help us break down foods in our body, and which help us give us more energy and therefore improve our life and our body. So I want you to go away with this now and think of where you've seen some of these before. There are plenty of examples of temperature affecting reactions, as well as concentration and surface area. So have a think about it and try and come up with some of your own that would have affected the rate of reactions in the real world.